All right, on to section 10.3. Today we're still talking about circles, but we're going to talk about chords and properties of chords. All right, in the same circle or in congruent circles, two minor arcs are congruent if and only if their intercepted chords are congruent. All right, so what this is saying is that arc AB here is going to be congruent to arc CD if indeed the intersecting chords are congruent. So if the chords are congruent, then the arcs are congruent. If the arcs are congruent, then the chords are congruent. So arc AB will be congruent to CD if and only if segment AB, which is the chord, is congruent to segment CD, which is the other chord. So in example 1, so in the diagram, circle A is congruent to circle D, BC is equal to EF, and the measure of arc EF is 125 degrees. Find the measure of BC. Well, since EF here is congruent to BC and EF is 125, then that means that BC has to be 125. So because BC and EF are congruent in congruent circles, the corresponding minor arcs, arc BC and arc EF, are congruent. So the measure of arc BC is equal to the measure of arc EF, which is 125 degrees. So if the chords are congruent, the arcs are congruent. Next theorem. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So the chord that does the cutting and the chord that is perpendicular to the other one is the diameter. So if QS here, if it is perpendicular to TR and it's the bisector of TR, then that means QS is the diameter. So do you see how you don't know QS technically is the diameter because there's no center of the circle for it to go through. However, if you have these other two properties, that it's perpendicular, so you see the 90-degree angle for perpendicular, and then you see that QS is cutting TR in half so that TP is congruent to PR. So then you can conclude that QS is the diameter. Alrighty, theorem 10.5. So if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So basically it's the same thing as this one here. What is this saying? Okay, if you don't know it's the diameter, but it cuts it in half and it's perpendicular, then you can say it's the diameter. Well, this one is if you know it's the diameter and it is perpendicular, then you can go ahead and say that it is indeed cutting that chord in half. And if it cuts the chord in half, then it is also cutting the arcs in half. So if segment EG is a diameter and EG is perpendicular to DF, then HD is equal to HF, and arc GF is going to be congruent to arc GD. So in this example 2, you'll see how it works. So it says use the diagram of circle E to find the length of BD. Well, since this is the diameter because it's a chord going through the center, you know it's perpendicular to the chord, then you know it's cutting that chord BD in half. So this side is 6, which means the other side is also going to be 6. So you can find the length of whole thing by adding 6 plus 6, and you get 12. All right, theorem 10.6, and you don't have to remember the names or the numbers here. It just, that's what the way the book goes. It gives it numbers. In the same circle or in congruent circle, two chords are congruent if and only if they are equidistant So remember that is equal distance from and only from the center. All right, so this one says if you have two chords right here, all right, and the chords are congruent, so the only way the chords are going to be congruent is if they are equidistant right in here to the center. All right, so CD here is going to be congruent to AB if and only if the little segment's inside. So if EF is congruent to EG. All right, so let's put that to use. So in the diagram of circle F, it's telling you that AB right here is equal to CD. So since the chords are equal, we know that that means that those chords are equidistant to the center. So we have some expressions here sitting on the distances to the center. Well, we know that if they're congruent, then they're equal. So we're going to set those expressions equal to each other because we need to find the length of EF. So if we solve for x and subtract 7x to each side, then divide by -4, our x is 2, and we can take this and plug it back in here because we have to find the length of EF. So 3 times 2 is going to give you 6 as the length of EF. So let's look at some of these checkpoints. Number 1, if the measure of arc TV is 121 degrees, then what is the length of RS? Well, remember, if the chords are congruent, see this chord is 6 and this chord is 6, that means the arcs are congruent. So the measure of arc RS is indeed the same at 121 degrees. Okay, and the next one, find the measures of arc CB, arc BE, and arc CE. All right, well, we know that DB here is indeed the diameter because it's going through the center. We have a diameter that is perpendicular to a chord. So if a diameter is perpendicular to the chord, it's cutting the chord in half and it's cutting the arcs in half. So if it's cutting the arcs in half, that means they're congruent, and congruent pieces have equal measures. So there we go again, setting things equal to each other. We're going to solve for x. So we get 5x is equal to 80. If we divide by 5, then that means x is 16. But the question is to find the measure of all these arcs. So if we take the 16 and we plug it back in, we have 80 minus 16, which gives us 64 degrees. So each arc is 64 degrees. So CB is 64 degrees, BE is 64 degrees, and then CE would just be the arc addition postulate. So 64 plus 64, 128 degrees. Now, in the next one, it says, all right, in the diagram in example 3, suppose AB is 27 and EF, GF are equal to 7. Find CD. All right, so if we look at this example 3 up here, and it's telling you that AB is 27. So let's just go ahead and, all righty, so let's redraw this. So we have here AB, here is CD, and we have our center here, which is F. And so we have A, B, C, D, E, F, G. And it's telling us that AB is 27, and we know that these distances in here are 7, so it wants us to find the length of CD. Well, if chords are equidistant from the center of the circle, then that means chords are indeed congruent. So CD is going to be the same exact as AB.